Your understanding of ventilation tactics is critical to saving lives, assisting in fire suppression, and reducing the amount of property damage from structure fires. Prompt vertical ventilation can prevent backdraft and flashover conditions, making interior operations more tenable for rescue and firefighting. In this program, we will present the factors that affect vertical ventilation and a variety of basic vertical ventilation procedures and cuts. The learning objectives are to define the principles of vertical ventilation and general safety precautions for rooftop operations, to present common roof types and roof construction and their role in vertical ventilation, to show how to determine the integrity of a roof system, to demonstrate how to open flat and pitched roofs using a square or rectangular cut, and to demonstrate the kerf cut, triangular cut, louvered cut, and trench cut. Vertical ventilation is the systematic removal of the byproducts of combustion, smoke, heat, gases, and sometimes flames through vertical channels in a structure fire. Most often, vertical ventilation means creating openings to allow these byproducts to exit from the top of the structure, the roof. Vertical ventilation can also involve moving the products of combustion from basements or multi-story structures through stairwells and other vertical openings. Vertical ventilation works because convection causes heat, smoke, and fire gases to rise to the highest point until trapped by the ceiling or roof. Once a vertical path is open for these byproducts to escape into the atmosphere, a clearer, cooler environment can often be created inside for firefighters to rescue victims and attack the fire. Using existing roof openings, such as scuttle hatches, skylights, and ventilating shafts for vertical ventilation, is preferred over cutting the roof. Use these openings if they are large enough and in the right location to vent the fire. The location of vertical ventilation is critical to success. Conditions for firefighter safety will be the first consideration before placing the opening. In general, however, the opening is as close to the seat of the fire as possible, but away from victims and rescue teams operating inside the structure. Start vertical ventilation only after the fire officer has determined if vertical ventilation is safe and when and where the opening should be made. Hose lines should be in place and attack crews ready. If assigned to the roof, observe these general safety precautions. Always wear full personal protective clothing and equipment, including SCBA. Start power tools on the ground to be sure they are working properly, but turn them off when transporting them up to the roof. Work in teams of at least 2, but no more than the minimum number of people needed to get the job done. Extend ladders at least 5 rungs above the roof line. An elevated platform should be even with the roof line or slightly above it. Sound the roof for structural integrity before stepping out on it. Travel across the roof on supporting beams or parapets. Observe the wind direction and work with the wind at your back or side to protect yourself from the smoke, heat, and gases that will surge through the opening. Notice if there are obstructions or excess weight on the roof that could make ventilation operations difficult or cause the roof to fail more quickly. If you are the ventilation team leader, stay in constant communication with the incident commander. Look around for electric wires and guy wires. Be cautious when working around wires. Plan 2 escape routes from the roof. They should be apart from each other, but close to the work area. Never create a ventilation opening between you and your escape route. Protect yourself and other team members from falling or slipping by working from roof ladders, aerial ladders, and elevated platforms whenever possible, and by using lifelines. Firmly secure roof ladders over the peak of the roof before operating from them. Ensure that all personnel are out of range of the axe and other power cutting tools. Make sure that the angle of the cut is away from your body. Be careful to avoid cutting the main structural supports of the roof when making the opening. Keep all team members back from the opening so they do not fall into it. And evacuate the roof as soon as the ventilation work is finished. Remember, there is absolutely no reason for staying on the roof after the opening is created, and a very good one for coming down. Every minute a fire burns is weakening the roof. Never assume you're safe until your feet are on solid ground. To be able to work safely on roofs and create openings in them to vent a fire, you must become knowledgeable about the roof types and roof construction in your area. The roof type and materials used in construction determines what procedures you will use and what equipment you will need to open ventilation holes. The best way for fire departments to know the roofs in their area and what materials are used in them is through inspection and pre-incident planning surveys. Roofs can be made in a wide variety of shapes and with many roof materials and coverings, but the three main types of roofs are pitched, flat, and arched. Flat roofs are most commonly found on apartment, commercial, and industrial buildings. They may have a slight incline to allow rain and the elements to drain off. Flat roofs may be made of wooden, concrete, or metal joists covered with sheathing. The sheathing is then covered with a layer of waterproof material and insulating material. They are often mopped with asphalt roofing tar. Some flat roofs do not have joists, but instead are made from concrete or precast gypsum. It's important to be aware that flat roofs often have a cockloft. A cockloft is an open space between the ceiling of the top floor and the roof. Flames can travel very rapidly from one end of the structure to another once they reach the cockloft. Fires in these spaces can rapidly weaken the roof. A pitched roof is elevated in the center and slopes down to the edges. Pitched roofs on houses are usually made from wood rafters or metal trusses that are installed directly from the ridge to the wall plate on top of the outer walls. Sheathing materials are applied over the entire roof. Pitched roofs usually have a covering of roofing felt applied before the shingles are laid. Shingles can be made of all types of materials, including wood, metal, slate, tile, or composite materials. Gypsum boards, about 2 inches or 50 millimeters thick, may be installed directly to the metal trusses instead of the wood sheathing. You would only know this by conducting inspection surveys before an emergency occurs. The third type of roof is the arched or curved roof, often found on warehouses, supermarkets, and bowling alleys. They're distinguished by the arched shape seen from outside. Like flat roofs, arched roofs have a cockloft, through which fire and heat can spread rapidly, weakening the roof. An additional hazard for arched roofs is that they are usually supported by bowstring trusses. These trusses have large spans of space between them, and when weakened, large sections of the roof may collapse without warning. Because of this danger and the difficulty of standing on these curved roofs, firefighters should ventilate an arched roof only from the safety of an elevated platform or aerial ladder extended to the roof. It's important to realize that roofs of all shapes and sizes can hide lightweight truss construction. Lightweight truss construction means the load-bearing components of the roof are made with an assembly of smaller and lightweight components rather than large solid beams, girders, and rafters. Lightweight truss construction holds special dangers for firefighters because when exposed to the heat and flames in a fire, these components weaken and collapse more quickly and suddenly than solid beam construction. Unless you know otherwise from pre-incident surveys, always assume modern construction uses trusses in the roof and use extreme caution. Concrete roofs also present special challenges in vertical ventilation. Poured in place and precast sections of concrete used mostly in commercial buildings are very fire resistant, but can fail if fire weakens their support structure. Because of the difficulty of cutting through concrete, even with special cutting equipment, you may need to use existing openings such as vents and skylights or horizontal ventilation to vent the fire. Metal roofs and metal roof decking are a special challenge in vertical ventilation. They are slippery and conduct heat more quickly than other materials. Special blades for cutting metal must be used. Firefighters may use hose streams to cool the roof down. Be aware that a heated metal roof may melt roof decking materials, causing dangerous flammable vapors to be released and fire to spread rapidly under the roof. Because metal roofs are supported by lightweight trusses, they may fail quickly with limited fire exposure. The integrity of the roof should be assessed before and during any operations on or around a roof involved in a fire. Knowing how to determine the roof's integrity is vital, because roof collapse is an imminent danger in all structure fires. In this program, we'll discuss basics that give you a heads up on the roof safety or integrity. First, the type of roof construction is important in judging the roof integrity in a fire situation. Pre-incident inspections and plans can provide valuable information about buildings that have bowstring trusses or lightweight wooden trusses. These types of roofs may fail early in a fire and with no warning. They are extremely dangerous to be working on or under. The elapsed time of the fire also gives you clues to the probable roof integrity. Since heat rises through convection, the ceilings and attics of low-rise buildings will be exposed to superheated products of combustion in fires that have gone beyond the incipient phase. These superheated gases can melt roof materials and cause the roof supports to burn. Be aware that tile or slate roofs show little visible signs when they are ready to fail. Automatic fire sprinkler systems are another important factor. If correctly engineered and installed, they significantly improve the roof's ability to withstand exposure to fire. Often, you cannot judge a roof's soundness until you are up close and personal. When you get to the roof level, look for these warning signs of a weakening roof: melting asphalt or dripping tar, smoke or fire coming from the roof, separation of the roof structure from the walls, sagging roof supports or structural failure of any portion of the building, a soft, spongy feel or sudden heat coming from below. If you observe any of these warning signs, retreat immediately from the roof. If you don't see signs of roof weakening, proceed cautiously. Keep your 2 escape routes in mind and have a plan for how you will get to them. Use your axe or other tool to sound for supports or rafters. The tool will bounce on a hollow area and will sound dull and solid on or near a support. You should be continuously assessing roof conditions for safety. Always plan your escape routes and leave the roof as soon as the job is done. Opening flat and pitched roofs is basic to ventilation procedures. In this program, we'll show you how to make a basic square or rectangular cut with hand tools and power tools to open a flat or pitched roof. Remember that at least 2 firefighters should be assigned to vertical ventilation. and a charged hose line should be in place to protect the vent team. Always work under supervision and maintain radio communications with Incident Command. Once the location for ventilation has been determined, here are the steps to open a square cut on a flat roof with hand tools. First, locate the roof supports by sounding with the axe. Mark the location for the opening by scratching a line on the roof with the pick head. Make the opening either rectangular or square to make it easier to repair later. Position yourself upwind of the cut. One large opening, about 4 by 4 feet or 1.2 by 1.2 meters, is better than several small ones. Remove the roof material by cutting it and pulling it out of the way. Cut the wood decking diagonally along the joist toward the hole. Avoid cutting the joist. Pry up the roof boards. When the opening is completely cut, push the handle of your pike pole or plaster hook through the roof to open the ceiling below. Be careful of a sudden updraft of heat and smoke. The same cut can be accomplished much quicker using a combination of hand tools and power tools. Be sure to test the saw on the ground by briefly running it at full throttle. Then turn it off and make sure the blade is completely stopped before transporting it. On the roof, again, you'll use hand tools to sound the roof to find support and to mark your cut. Another firefighter secures the cutter's position from behind to ensure that he doesn't fall while using the cutting tool. Be sure that everyone stays clear of any moving parts of the chainsaw or rotary saw. Run the saw at full throttle while it is in contact with the roof decking to reduce the chance of binding. Make the first cut parallel to the roof support, then a triangular cut at the corner closest to you. Make 2 cuts perpendicular to the joist, being careful not to cut the joist. Then make the final cut parallel to the joist. Use a hand tool to pull the cut section of the roof decking out. Push through the hole to open the ceiling. The procedures for opening a pitched roof with hand tools are similar to those for flat roofs, but the incline requires you to take additional precautions to keep from slipping off. Place a roof ladder upwind from where the hole will be at the highest point of the roof, above the fire area. Sound for the supports or rafters and mark their location. Rip off the shingles or felt to permit the initial cut. When using an axe, it is especially important to remove all of the roof covering before cutting. Alongside a rafter, cut the sheathing to the size of the opening. Be careful to not cut the rafters. Then cut the opposite side of the opening. Remove the sheathing boards. Push through the hole to open the ceiling. The square cut can be quickly expanded by extending the cut in either direction. In addition to the rectangular cut, you'll need to know several other cuts to achieve good vertical ventilation. In this program, we'll demonstrate 4 roof cuts and their objectives in vertical ventilation. The kerf cut is a simple slice into the roof that is the same width as the blade. It's an inspection cut to determine the direction of fire spread. The triangular cut is a small triangular cut made in between roof supports. To make a triangular cut, start by sounding the roof to locate supports. Make the first cut just inside the support member, cutting diagonally toward the next support. Start the second cut at the same end, making a V. make the final intersecting cut along the support member. The triangular cut can be used in a variety of ways. It can be an inspection hole to determine fire conditions under the roof. It can be expanded to form a rectangular cut. The triangular cut is an effective cut for metal roof decking because it prevents the decking from rolling away as it is cut, creating a dangerous slide. Several triangular cuts may be needed to create adequate ventilation. Another common cut is the louvered cut, which is particularly useful for opening flat or pitched roofs with plywood decking. To make a louvered cut, first sound the roof with a tool to locate roof supports or joists. Make 2 parallel cuts perpendicular to the supports. Be careful not to cut through roof supports. Make 2 parallel cuts to the roof supports and between pairs of joists to form a rectangle. Strike the nearest side of each section of the roof to tip it in, using the middle support as leverage. By continuing this cutting pattern in any direction, you can rapidly open a large section of the roof. Trench or strip ventilation is a type of vertical ventilation used to stop the spread of fire. In trench ventilation, a large trench-type hole from 2 to 4 feet or 0.6 to 1.2 meters wide is cut from one exterior wall to the opposite exterior wall. This cut is usually made well ahead of the advancing fire. It sets up a defensive line where the fire's progress will be halted. Ventilation is an important tool in fire suppression, and it becomes more important as buildings become more and more energy efficient. In this program on ventilation, we have shown many of the factors that affect vertical ventilation. You have seen the basic principles of vertical ventilation and safety precautions for rooftop operations, how roof types and construction apply to vertical ventilation, how to assess the integrity of a roof to ensure the safety of roof operations, how to create a square or rectangular ventilation opening on flat or pitched roofs, and how to create 4 other basic ventilation cuts: the kerf cut, triangular cut, louvered cut, and trench cut. Training and drilling on how to perform ventilation for the many roof types in your jurisdiction can be exhausting and time-consuming. But when the heat is building up and hose crews and victims are relying on you, your time and effort will be well spent.